Robot here from Vespa Motorsport and ScooterWest.com. Today I have a 2006 Vespa GTS 250, and this is a problem that plagues almost all the GTS 250s, starting in 2006 all the way up to 2009. By 2010, when the GTS, the Super 300, GTS 300 came out, they improved the voltage regulator, and that's what I'm holding here. So if your old GTS still has a voltage regulator that's original to the scooter, it's likely going to fail. For instance, the scooter has seen some life outside, kind of has a lot of little nicks and bruises on it, not from crashes, but probably from being bumped around in somebody's backyard. But it only has 1,400 miles on it, and the customer who now owns it is prepping it and wants to use the scooter. And right away, he noticed the check engine light comes on. He looked at one of my prior videos, checked the voltage on the battery, and it's through the roof. As with a professional shop, I want to definitely diagnose what it is and see what other codes are in the system. The check engine light is on whenever you start the scooter. Headlight bulb's burned out as well. So it's a little bonus right here. I'm going to show you how to use like the handheld diagnostic tool. It's Tool Scan M4. Kind of covered out in a prior video, the basics, but pretty powerful tool. We use it here in the service department over the really, really expensive subscription-based Piaggio pads. There's some things we still have to use the Piaggio diagnostic tool, specifically on the newer scooters, but for any of the older fuel-injected Vespas, this older scan tool works just fine. So I already got the battery cover open. FYI, this is not correct. We're going to fix all that. So that's a bonus section of my video. I'm going to correct the placement of battery. There's not even a battery tray in here. But that can, sometimes it will short against the metal frame right there. You can burn up the wiring. But for now, there's a fresh battery in there. So the customer's already put a new battery. Boot up the scan tool right here. And on most of the GTSs, or pretty much all the GTSs, it's going to be underneath the seat where the pet carrier is. Diagnostic connector, that is. So on this model, it's going to be right here. So the camera's not going to get it, but I'll pull it out. Pretty easy to locate. It's got like a little pigtail on it. And this is the older standard for the diagnostic on Piaggio and Vespa scooters. It's got the 3 pins on it. Get the right connector. Make sure the OBD part is in there. We're going to need to turn the ignition on. You don't need to start the scooter. So just to show you the voltage, actually I will start the scooter. I'm going to pull up the voltage, and it's testing the voltage, but see, we're going to go back and do that again. 15.5 volts. That's far, far too high for a normal battery. That battery is going to get fried in no time. So that was at idle. Can't imagine how high it goes when you rev up the scooter. But a proper working voltage regulator should never go above 14.5, 14.4 volts. So definitely your voltage is pretty high. So using that, we're going to go into the diagnostics. The ignition's still on, but I turned off the engine because I want to hear that loud muffler. And we're going to go down to Vespa. Okay, load the software. Takes a moment. Go down to, you can probably pick GTV, GTS, or even the GT60, which has the same motor, but does have specifics there. So there's quite a few different displacements and variations. 300, there's lots of different ones with different ABS systems. Sometimes it's not going to work. You can just try another one, but there's only one for 250, so we'll go ahead and hit that. 2005 and later, that's when in Europe it started, so we'll do that. Could do quick test, pull up the control unit. Some of them did have ABS, never sold here, the 250s. So we're at the screen where it shows the ECM. which is your engine control module under here, and ABS. This scooter doesn't have that, so we're going to go ahead. You can go up or down, but we'll go ahead and click the ECM. Make sure ignition's on. We know that. And a lot of stuff you can do in here. Read fault codes, hit OK. F1 are OK. And I think there's a couple of them. So there's a historic code for the lambda probe, which is the O2 sensor. Open circuit, or the ratio is off. Most likely the fuel ratio is incorrect. It's either at the upper or lower limit. That could be from an air leak, possibly from that old dry intake manifold. Or it could even possibly be the O2 sensor, but probably not. The O2 sensors are generally pretty reliable, you know, unless they have high miles. Could be bad fuel, could be a clogged injector. A lot of reasons why you'd have that error, but it's a historic error. We're going to go to the next one. And this is the one that the P0560 is the battery voltage over the maximum threshold. So that kind of verifies our voltage regulator is definitely bad, and that's a historic. And sometimes you'll get other ones, immobilizer, serial line open, short circuit. That could be an anomaly. But if you were trying to troubleshoot an immobilizer issue, that might help you. But I suspect that's an anomaly from the voltage being way over the voltage threshold, and it would trigger an error like that. So what I'm going to do is go back. We're going to clear all the fault codes. Hit F1, and I'm going to go ahead and change that voltage regulator. If I was running the scooter, you'd also see the over voltage active, and I can actually see the real-time voltage. You can find that in the data stream function, and it's probably hitting 18, 19, maybe, you know, higher voltage, which is why the headlights burned out, and you can end up burning out more bulbs and possibly damaging the engine computer and the battery eventually if you keep on running it with a bad voltage regulator. So enough of me talking, let's get that voltage regulator changed out. So first things first, get this glove box out of here. It's quite a few steps. So on the 250 model, you can just push the glove box to open a door, push the key. I can tell you one thing, the hinge is loose. So we'll fix that when we have it all apart. There's this large center screw right here. Maybe a wise idea also to disconnect the battery, but it's not necessary. Usually the worst thing you could do is bump something on the voltage regulator and blow a fuse. And then we'll remove the pair of knee pad covers, as I like to call them. So there's a single screw that holds each one of those. And you don't want to do this with a hot engine, so make sure the coolant reservoir's cap is make sure the coolant reservoir is cool, and then you could use the tool SN if the cap's really, really tight. Got something in there. There's nice coolant there, it's not too bad looking. And you have another pair of screws just with the regular Phillips, each one of these corners here. Then we'll move down in the center. I can see this screw is crooked, or they drove it in the wrong angle. I'm not sure what's going on there. Short screw, and then you have a longer screw on the outside. And if you look back at my past videos, I've showed how to remove the glove box. All I can tell you is the newer they are, the more difficult they are to remove. They've jammed more and more stuff behind the glove box. They have more hidden fasteners, so it's definitely a little trickier on anything newer. This generation is a little easier to take apart. And now we need to move up to the front. So we'll use a pry tool like this, go in from the side on this badge, or push on that little tab and it pries away. Single screw under here. And this screw is kind of a coarse plastic threading. Look at that dirt in there. It's like it's been in somebody's backyard for a long time with all that dirt built up. The scooter's nearly 20 years old. Might need a new bulb, so maybe we'll check that. Like I said, if the voltage regulator fails over voltage, oftentimes you'll smoke a bunch of the bulbs. 2 screws under here. And these are like the medium length screws. I'm taking them all out quick. I know exactly where they all go in the lengths. If you're not familiar, I would suggest like IDing the screws, because you don't want to put a long screw in a location where you're supposed to have a short screw, and then vice versa where you have a short screw, it doesn't quite reach. I don't know what's in here. I think I know what's going on. Had a plant in the yard growing inside the scooter at one time. All right, so here's the tricky part, kind of dismantling the glove box. So I have that screw just needs to pull out. Sometimes also when you see all that stuff falling out, could possibly be rodents that got into the scooter. Not unheard of. 2 lifts over from us, that scooter's getting a complete wiring harness because the rodents decide to nibble on not just 1 or 2 wires that are easy to fix, but nibbled on major parts of the wiring harness. So the best thing to do is use your scooter regular if it's got to be outside, or park it somewhere where the rodents don't get, like a garage. And it keeps the weather off it as well. So I'm kind of pulling the glove box away. Obviously it's much easier if you do take the handlebar covers off, but we're not going to do that. So it kind of gets caught right here, and you kind of just have to give it a little bit of force pulling down because you're dodging the filler neck and the fan. So I'm going to pull the bottom out a little bit, and it kind of gives you a little bit more space. And sometimes these clips want to fall off. Not really an issue right here. They're all nice and tight. Then I'm kind of splitting the glove box and pulling it out. But see these little clips? They tend to want to fall off. CM 017410 if you need to get replacement clips. Have them on the Scooter West web store. I don't think the rodents were in here, but the plants certainly got in here. So this is a little tricky. This is your manual release lever for the seat. I want to get the barrel out of that manual release, and it's a little bit of a trick. Don't necessarily need to do that, but I disengage it from this little plastic lever here. I'm going to move on to the other side, take the needle nose, and carefully wiggle the cable out. I want to make it easier. This is not 100% necessary. You can just leave the glove box in place. It's kind of in the way, but I want to get it out of here so the video. And we'll go ahead and pull the cable out. Kind of has a plastic snap. Barrel's kind of getting caught in there. A couple other things to disconnect. There's a button right here. The connector just pulls right off. Perfect time to put some dielectric grease. There's some extra auxiliary connectors for alarm system and other accessories. Then you got the fuse holder. I'll pull this little plastic tab in the center up very carefully because it is pretty fragile, and then wiggle the fuse holder out from the back. So there you go. Got the fuse holder out. Check all the fuses. I'm going to check all the systems before I assemble and make sure all the lights are working. I know the headlight's out. So, and sometimes they have a little clip that no longer sticks that would have held the this seat release cable. It's not 100% necessary, but you have that available if you do want to replace it. And while I'm at it, I'm going to show you why the glove box is loose. I see exactly. Somebody was just hard on this glove box. They like got the hinges on the wrong side. So it's just a simple plastic hinge. We'll go ahead and pull this out. Put the hinge and the little thing. I think somebody was just hard on it because there's no reason for it to Trying to do this as one-handed if I can. Put that clip right back in place. Probably best to even just close the glove box door. That'll be even easier. There we go. So it's a little bit mangled in there. Somebody was just heavy-handed on the glove box door at some point. And this screw doesn't have much travel, so you got to be extra careful with the screw. With screws that go into plastic, you want to go backwards, and then so you're not cutting new threads is the idea behind that. Go ahead and tighten this all the way down. The other one it's fine, it's just a little bit loose. And I'm going to actuate the little lever. Now the seat, it's all opening and closing just fine. The glove box door is no longer loose. So definitely a good thing to fix while you have it all apart. All right, so you gotta take these side skirts off because next we're gonna be removing the glove box. So in the front, there's a single screw, both sides. And they are different screws between the left and right, so keep it with the appropriate side. And I'm gonna take a 10mm combo wrench right here, and right about here behind there is a single flange nut, holds the rear of this side skirt here. And start pulling away. It's got these rubber bumps. You see more of that yard dirt in there. That's the problem with aftermarket pipes. This muffler, these were never really that great a quality. It's obviously hitting right here, damaging this plastic part. I'm not really a big fan of most aftermarket exhaust systems. It sounds cool, but these typically fall apart pretty quick. I sold them for a short while in the mid-2000s. So I'm gonna take off the end cap while I'm down here. Need that out of the way as well. It's even dislodged. So maybe this trim is in bad shape on your scooter. It's perfect time to do this trim because we're tearing the scooter down to that level. So I'm gonna leave this on both sides. I'm gonna move on to the other side. And again, while I'm at it, there's one screw here for the floorboard. Might as well get this out of the way. Usually if it's pretty tight, you could use a number 3 screwdriver. And optional, you could remove both of the foot pegs. It does make the floorboard a lot easier to remove. They're with 5mm Allens, but they are a little difficult to access, but up to you if you want to remove those. Next step for the floorboard is you're going to pull this outer floor strip out. Just using my fingers to kind of pry these little tabs out. It's really stubborn. Leave it out in the heat. The sun will kind of help. And you only need to pull it back this far. So now you have access to the 3 screws that hold the floorboard to the frame of the scooter. And the last screw on the side. These things are pretty dirty. A lot of dirt is built up in here. I'd almost take the scooter while it's apart and take it to the pressure washer. And then one more screw in the middle. So the battery tray is already missing, which is a good thing. We don't need that in the way. The single screw in the middle here. All right, so now we're ready to take the floorboard off. If you wanted to really protect everything, you could put painter's tape all on the body up here, or just be a little extra careful as you're stretching the floorboard past the foot pegs there. So see how I'm kind of pulling the floorboard away? And as you're pulling away, you need to start pulling up and towards the front of the scooter. So it's a little bit of a motion. Got that side. Looks like there's a crack on the center of the floorboard, so I want to be careful not to crack this more. So I'm kind of working on the other side, doing the same thing. And if you really want to make it easy, you could take the fan off because the fan kind of gets in the way, but it's not necessary. we go. Let's see what kind of crumbs are under here. Not too many. So what do we have access to right here? There's our 3-phase connection from the stator plate, and that's why I had to pull this off, because you're not going to reach down there and get to that connector. We got to pull this radiator away. So let's get right to it. And there's your voltage regulator right up in the front. All right, so we're going to go ahead and pull the right radiator away. There's a single screw in this upper left corner right here. Keep track of the hardware that comes off this radiator. And you're going to need a 10mm socket to get these 3 nuts that hold the radiator to the frame. They're like threaded studs that are built into the frame. More junk right there. So other considerations why the scooter's all apart, and it's pretty much 20 years old right now. All these radiator hoses are pretty old, and generally they're really reliable. But just keep in mind, sometimes these joints might start leaking. See how there's a little corrosion around that? Probably isn't a bad idea to run the scooter all the way up to normal operating temperature until the cooling fan turns on. Make sure the fan turns. I see scooters that sit for a while, the fan will be stuck. And with that scan tool, you can actually activate the fan, make sure it works before you just overheat the motor. These coolant tanks sometimes fail just from age, so keep in mind this plastic tank, 20 years old. So, you know, it kind of comes with the territory. I don't care how low the miles are. This is a perfect example. The mileage is really low, but this poor scooter is pretty weathered. So you can kind of pull this all away, and you can see it's still pretty difficult to get this out. You could also undo this junction up here, gives you a little extra space, and we'll probably cut the zip ties so I could kind of pull the radiator away, and then the shroud that the regulator is mounted on, I can kind of separate that as well. So in the front, there's a single screw that holds this little 4-way junction for the coolant. Sorry I don't have that on camera, but I went ahead and removed that screw. And kind of remember that there's some zip ties that hold things all in place right here. So oftentimes if I'm gonna put zip ties back in, I use a paint pen and just make 2 little marks, something like that. So I just remember that zip ties went there. Obviously they're inexpensive, so you just cut them out of the way, but we need the clearance. There's also the 4-way union at the bottom. It may be a good idea to also loosen this fastener, which is identical, looks nearly identical to that one that's in the front, the other 4-way junction. And the idea being is everything's going to move around, so I got a lot more space. Be careful about putting tools down here. They could, you know, with hardware sometimes down in the bottom of the frame. This is the gusset of the frame. Then you got the monocoque body is kind of all welded in different parts to this gusset right here. So at this point you can see the radiator easily kind of pulls away, and you know, some of these hoses go through onto the other side, but now I have this shroud under here with the voltage regulator. So that's attached to the frame, and you can see this regulator's kind of got a square profile. That's typically the variation that has the failures on it. So you have this single connector down here for the voltage regulator. This is going to the engine or the main harness, and you have this little tab right here, and oftentimes this connector can be a little stuck. It's not really the best spot for the connector in my opinion. You get moisture in there, it could corrode it. So go ahead, wiggle it out. I'm kind of using the flat screwdriver to kind of help pull it out. Double check those blade terminals, make sure not burnt, because these connectors sometimes will burn up. And then you have the DC connection under here. There's another zip tie I need to cut. It's actually zip tied right up at the top up here. So clip that little zip tie. It has a little rubber tubing on there, so I keep that in mind when I put a replacement zip tie. And it looks like the connector kind of goes in front of the this radiator hose here. So this thing is a big rubber boot that does keep moisture off the connector. The thing with this connector is this has live DC power, so it's more likely to have galvanic corrosion. The other one's alternating current, so it's only when the scooter's running, so probably less likely to have an issue. So that actually pulled right out. Now the regulator with this shroud is all separated, but this boot, I want to push this up enough so I can expose the connector. And you got to be careful with this connector because, like I said, it's got live 12 volt all the time unless you disconnect the battery. You know, don't short it with your needle nose, but I do want to pull it out so I can make the connection, make sure the assurance locking tab locks when I put the new regulator. The last thing I want is put a regulator in there and it doesn't charge the scooter. So got the connector pulled out and you can see the little tab right there. So it's held in place with two 6mm fasteners and an 8mm ratchet. And there you go, it says Ducati right there. And that means it's gonna fail. There's no ifs, ands, or buts. The original Ducati ones always fail. Replacement regulators are made in Asia. They never have problems, is my experience. So there's the regulator. Get rid of that part. Good quality replacement. Go ahead and get the screw started. And go ahead and snug these, about 7.5 foot-pounds. All right. So you have the connector that goes all the way down. We're not going to mess with that right this moment. And this DC connection we're going to make first. So kind of wrapped around the backside of that hose right there. It's got this locking tab. You line that up with the tab on this. That's why I pulled it away. And make sure it locks. Looks like it's locked in place, and we'll pull that rubber boot. You could even, if you wanted to, you could pull the, put some dielectric grease on there. And now we're gonna get this radiator shroud back in place. Kind of pull the radiator out of the way. So you don't pinch the make sure this hose doesn't get pinched. So all this wiring, these hoses are all going to go on the front side. Make sure none of the other wires on the frame are going to get pinched as well. There we go. And then we'll line the radiator with those fasteners right there. Kind of route that down. Two ways to go about this. There's enough room in this channel to route the wiring, or you could go behind it. Typically, before I even put the screws, I'm going to actually get the wiring behind this here. And then route it between these. They put a little bit of this, that plastic there to kind of keep the wires from chafing. Then you could plug the connector right in. Makes that nice little click. Means it's locked in place.
All right, so I have a socket. I'm gonna get each of these nuts to hold the whole radiator in place. Already installed. Tighten them all up. Take my Phillips screw driver and put that single screw in the upper position right there. Start pretty much reassembling. I'll get some zip ties, kind of secure the wiring just the way it was to begin with. We'll do the same with that fastener up in the front as well that holds that junction. Don't leave tools behind. So we'll go ahead and put zip ties around this wiring and the hose here. Sometimes it might have been easier if I did put this zip tie in before I put that back in place, but easy enough to pull that right through. The same right there, you can see the hole where the wiring goes. Might have to pull the main wiring away a little bit so you can see what's going on. You can not go around the regular wire, or you could. I don't think it makes much of a difference. Tuck that wiring in there. So. Yeah, I am gonna move this on the other side. I think I made a little mistake on that. Then on that side, just to keep things from, there we go. So now that's sitting in place. So I'm just spraying some silicone spray. Kind of helps everything slide around because I want to get this boot further up without choking up the wires here. Sorry, I'm on the wrong side. Pull that connector out. Make that connection once again. Pull that down. And the idea is you want to have this wiring. The reason you have the zip tie up here is you have the toolbox that goes in this little cavity right here. So it needs to be routed just the way it originally was set up. And there's that little plastic tube. We'll go around that radiator hose that goes into the bottom of the coolant tank and around that top of that little wiring there. And there we go. So that's all kind of tucked in there the way it should be from the factory. And the turn signal wire, you could move, somebody has that upside down, but that should be on the bottom here. And route that wiring kind of right there. So when I put the glove box back on, the little tube that goes in here that holds your tools is gonna miss all those cables. And one last zip tie right here that they had around these lower hoses. Don't tighten them too much because it could collapse the hose. But that's pretty much how it's all set up. Anything else you want to do? Like I said, probably a good idea to check the operation of the fan. We're gonna rework the battery, which is
These 2006, 2007s, they had a really crappy battery that they're maintenance type, where you need to check the acid, and the terminals are from the side. Well, what a lot of people do is they order a battery for a GTS, which is usually a YTX 12BS or a YTX 14BS in most GTSs, except for 2006 and 2007. And they just drop it in. The battery terminals are in the wrong spot because originally they were over there. The wires don't quite reach. They get rid of the battery tray. So you know the problem? This battery just moves around. Battery terminals are going to come loose in no time. So I'm going to correct that. There's an actual specific Piaggio part number for the battery tray for the YTX 12BS and the YTX 14BS. So customer already bought the YTX 14BS, and that's the larger capacity battery anyway, so it's a good thing. So we'll go ahead and jump into this, especially considering the floorboard's out of the way. It makes for an easy job. All right, so the battery terminals, we'll go ahead and pull this battery straight out. And you can see there's even some rust in the bottom of the frame. That's why you need to run a battery tray. There's this extra little wire in here. That goes to your ignition coil that's right here. Just recently had a customer text me, like, how do you replace the ignition coil? Well, you get it to this part. There's two fasteners back here, and it pulls out from this cavity when you pull the battery out. So not the easiest job, but those ignition coils are extremely reliable in my opinion. The actual spark plug wires aren't. All right, so I have the OEM part for the 14 amp, the YTX 14 battery tray, 639853, so 639853, the original Piaggio part. And if the customer didn't buy the 14 amp battery, I probably would have got the 12 amp battery tray. That one's a little cheaper. It's a little bit taller. So there's a bigger side and a little alignment peg, so it just drops right into the frame like that. And there's also a battery strap, and is what I want to do is configure the battery terminals in the correct orientation. The only problem is the negative is on the outside. So the nuts are already in place. I'm going to carefully drop the battery right in place. So what I'm going to need to do with this negative terminal, I'm going to need to extend it. You need to take extra caution because there's already been some problems. You see some chafing right here. This one you have extra length in there, and there's like the body cavity that goes back in there, and even on the later GTSs you can just extend it. So there's two ways you could do this. This terminal is already nicely crimped on here. It needs a little bit of cleanup. I'll actually trim it a little shorter and then drill a little hole in it, and then we'll extend this connection right here. So kind of do this with something holding the thing, because this is made out of brass. You may want to vacuum your chips out. Right to about 1/4 inch. So we're going to go ahead and cut the terminal down since you don't need that wing on it anymore. So just like that. And we'll go ahead and get this nice and clean, where it's nice, clean brass. I use the compressed air. I'm going to clean up all the shavings because I don't have enough room to really pull this up. You could put a tray underneath. So there's our positive terminal, and it will be just perfect right on that. The negative terminal, we're going to need to extend that. So there's that lead right there for your voltage regulator connection. And while we're at it, I don't really want to, I could crimp, or if you have a very large soldering iron, you could extend this. And the newer, if you bought a replacement wiring harness for a GTS 250, it would be the newer design wiring harness for this style battery. So this would already be the correct length. This is only the early GTSs. So here I made a little extension, and this isn't normal wire that you just buy from your local auto parts store. This is actually, I think it's 8 gauge or 6 gauge wire, and I have a crimp tool for these large lugs on it. Don't really want to mess around and do something haphazard on this kind of stuff, just because it kind of carries high current. So I have a 6mm screw through, and then I'll put a star washer, kind of make sure it doesn't lock, and then as an extra preventive measure, I'm going to put a nylock nut. And I use the button head screw just to kind of keep the profile low. And we'll get our 10mm and just go ahead and tighten that up. And since it is ground, you don't necessarily need to insulate it, but I'm going to put a piece of either heat shrink over it and just kind of keep it insulated so it's not rubbing through anything. So I put a piece of heat shrink over it, and then I have a new battery terminal that will reach the negative. All right, so I got a little piece of tubing over here just to kind of clean up the look. Nice thing is the original wiring does have this pretty thick fiberglass sleeve on there. So typically with a battery, you want to hook up your positive first. So push that back. We're going to go ahead and make the positive connection. And the square nuts in there, so make sure that's nice and tight. And sometimes you'll get a little spark when you make that negative connection. So kind of want to, we'll route this. When we get the floorboard on, we'll see how we can get this where it's all routed nice. Sometimes you want to use a number 3 Phillips, and then pretty important to put this battery strap in place. Looks like somebody already put some Torx screws in here. So the all-important battery strap kind of holds the battery from vibrating around, and that can do 2 things to the battery. The terminals can loosen up, and you end up with glitches, and a scooter might not start or stall out. And it also it's hard on the battery, because sometimes you have a battery failure because the lead separators or the internal structure of the battery may fall apart from the vibration. So the battery terminals, originally the customer had on this side and wasn't sure what to do, but that's probably the only way you're going to fix this. Let's extend that negative terminal. There is also a sealed replacement for the 10 amp hour battery, but in some ways this is an upgrade because we're now at a 14 amp hour battery. Let me blow some of this dust out of here off camera, and we'll get the floorboard back in place. All right, so make sure all the clips are in place. Some models have a clip on both sides, the 4 clips for the battery, and then there's these little square nuts that are in the front. Go ahead and we'll rock the floorboard in just like this. Like I said, perfect time to change out the leg shield edge strips. Pretty much the reverse steps of pulling There we go. And that's fine right there. There's just enough of a gap. I think I can kind of rework it a little bit where the battery terminal wire comes out. You know what I think I will do? I will make a little notch right there. And the wire wants to come out there. There's a little bit of the and I made a little notch for the wire to slide through. Sometimes you can actually pull the floorboard out, the foot peg out, and that makes it actually a little easier to get this back into the channel of the floorboard. The
the strip. Put that closed up again. Start with the center screw right here. And pretty much just replace all the screws in the floorboard and the 2 screws on each of the side. We'll snap these back in place. All right, floorboard's in. Just want to check one more thing. I have this on voltmeter. So our battery is nice and charged. Let's see, 12.8, that's a fully charged battery. Don't want to see 15.5 like I did. So we're just going to start it for a moment, make sure I see charging voltage. So it drops a bunch because bike's on. And there you go. So it's got charging, normal charging voltage now. And I could put the cover back on. So whenever you do, a job like that, you want to make sure there's charging voltage, because if you missed a connector or that's where it would show up. You wouldn't know, it would just eventually kill the battery. I could also have plugged in the scan tool. If you have the scan tool, I just happen to have the voltmeter there. Show a little bit easier visual indication. And we'll get the glove box on. And looking around, I see the headlights burned out, the taillights burned out. Same with the city light. In both the headlight and that little horn cover city light is out too. So it definitely burned out some bulbs. We'll replace some of those lamps. Put this down just like that. Got our glove box, so in here, there's this little tab that you push. That's what opens it. Make sure these clips are in place. The clips are here. The last thing you want to do is put it all together and the clips are missing. Sometimes you just squeeze them, put them back in place. Everything else looks good. We'll see if we can get the screws to line up a little better than how they were from possibly the factory. So set that. And get the fuse holder back in place, just snaps right in place. So all this stuff assembles quite easily. So that's in place. Leave that needle nose aside. A little clip for all this wiring here. Plug the seat pop button in. Even actuate it just to hear it. Then I have our control cable for the manual seat release. Just snaps right in from the back side here. Get the key out of the way. So this little lever right here, it sometimes wants to fold back. You could put a rubber band around it to hold it in place. I typically just hold this little lever. We'll connect that cable in a moment as well. We're gonna have to stretch this around the handlebars for the lower stem right here. Taking care not to damage that immobilizer antenna. Now lifting it up, looking where things are lining up. There you go. So see that edge is all correct right there. And my actuator is actually on the wrong, for the glove box is on the wrong side, so I'm gonna need to mess with that. You need to reach back there and get this all on the right side. There we go. So, and the first fastener you wanna get back in place is the center most fastener right here. So get this all in the grooves. All right, so we'll start with the center fastener here. The glove box is a little out of position again, but we'll take a look at this. All right, that's nice and tight. Moment of truth. See that little latch? That's working. So that's pretty important that that works before we go any further. Make sure everything's all lined up. So the longest screws, they're gonna go in these outermost positions. So I would say that's about 30 millimeters long, 1.25 inches. Don't need the rag anymore. And then locate the shortest screw, which I would say is about 5/8 of an inch. And sometimes this is the one that's hard to get lined up with the peg, and they end up going into the wrong direction. And then you have 4 remaining screws that are all the same length, kind of just slightly longer than what you just used, just like that. And these screws are gonna go in the left and right corners. You don't want to over tighten these because they're going into like a little stainless speed nut clip. They don't need to be all that tight, but you can feel when they pull some tension on the plastic, and that's about where you want to stop. And then there's going to be a pair of screws in the front, again going into those speed nuts. And the last 2 screws, we got this corner right here. Kind of get that all positioned. This is the one that was kind of not installed correctly, so let's see if we can get that. Before we put the knee pad back in place, obviously the radiator cap goes back on. And just pretty much hand tight, about as tight as you can get it is all you need to go. Moment of truth. Glove box works. And last but not least is the manual seat release cable. A little tricky to do, but you pretty much need to line up the barrel with the little slot with a pair of needle nose. There you go. And now it's all working. Open the seat without, somebody's missing the toolbox, but that's that protrusion that goes through where I had the wiring specifically routed. That's all working perfect now. I'm gonna leave the horn cover off. We'll go ahead and put a light there, but pretty much sums it up. We know the scooter is now charging at the right rate and have that all fixed. So look out for the next video. I'm gonna change the tail light, the running light, and the headlight. Something that's a pretty simple standalone video. So that will be my next video. See you on the next one.